Right. This video will look at using laws of logarithms to simplify expressions. So the first question says express this in terms of sum and difference. So we need to separate both of those. So I'm just going to do the quotient law to begin with. So I'll say that that's the same as log base b of p to the fourth q to the sixth minus log base b of m to the 5 b to the ninth. Okay, now I could leave it like that. That's a difference right there. But since I have two terms in each one of these logarithms, I can use the product rule to separate those as well. And so I'm going to treat this as a group and this as a group. So the first one, that's a product rule. So I can split that apart. So log base b of p to the fourth plus log base b of q to the sixth, okay, minus, this one would be log base b of m to the fifth plus log base b of b to the ninth. Now, you'll probably see now why I put those brackets in, because this negative sign has to apply to both of those. So let me rewrite it, and what I'm going to do is I'll apply this negative sign to both, and I'll also use the power rule to bring the exponents out to the front. So this would be 4 log base b of p plus 6 log base b of q, okay, minus 5 log base b of m, minus 9 log base b of b. Okay, but here log base b of b is 1. And so I can get rid of that part. So this will be my answer. And hopefully that's one of the answers that are there. Looks like it's this one. Okay, next question. Expresses the sum or difference of logarithms without exponents, same thing. But this one has a cube root in it. So the first thing I'll do is I'll take and whatever's underneath the square root there, y cubed z squared, I'll raise all of this to, since it's a cube root, I'm going to raise that to the 1/3. And then I can apply that 1/3 to each of the exponents inside there. So I'd have log base b of x to the 5/3 over y to the 3/3 z to the 2/3. And then I can do the same thing as I did above there, where I split it into, use the quotient rule to split it. So log base b of this top stuff minus log base b of this stuff, and make sure you put those in brackets so you don't mess up that negative sign thing. Okay, that's with that one. Here's another one. Number 8 expresses a single log. So in order for him to express as a single log, I have to have like ln of something minus ln of something. And then I could express it as single log of ln of something over something. But I have to have these things looking like that. So the cube root bothers me, and this 3 in front bothers me. Let's start with the cube root. So this will be ln of x to the 4th minus 3 ln of x to the 1/3. Okay, cube root changed to 1/3. Now I can take this 3 according to the power law and put it back up there. So that would be ln of x to the 4th minus ln of x, okay, 3 times a third would just be, that would just be 1. Yeah, so now I could combine these. So to put it as a single logarithm, so it'd be ln of x to the 4th divided by x to the 1st. Or dividing common bases, subtract their exponents. So it'd be ln of x cubed, which you could rewrite as 3 ln x. I think the answer key has that one, but both those would be correct. Number 9 expresses a single logarithm. Okay, I've got big square brackets here. So let's apply the product rule in there. So I'll just leave the ln of x and this minus 3 out front. And then I'm going to combine those. So it'd be ln of x plus 7 times x minus 7. I guess that should have been square. Now if I FOIL that together, I'd get ln of x minus 3 times the ln of x squared minus 7x plus 7x, they'd cancel, minus 49. Okay, I'm almost at that stage where I have ln of something, but this 3 out front bothers me. I can use the power rule, and I can put that back right there. So this would be ln of x minus the ln of x squared minus 49 cubed. Now I can use, because it's ln of something equal minus ln of something, I can use my quotient law. So x would be on the numerator, and x squared minus 49 cubed would be on the denominator. Probably stop there. Okay, the last question. Oh no, I got one more after this one. Tells you that they say the ln of a is that, and the ln of 5 is that. Then they say use these values to figure out what the log base a of 50 is. Well, 50 is not 2 or 5. But maybe I can break 50 up into numbers, products, or factors that multiply to 50. So like I could break that up into, say, 25 times 2. So there's a 2, and that, and 25 is the same as 5 times 5. So I could write this as 5 times 5 times 2. Then I can use the product rule to say, well, that's log base a of 5 plus log base a of 5 plus log base a of 2. But I know what this is right over there. It's 0.699. So I'll write 0.69 for that. Notice there's no ln in front of that because this whole thing is equal to 0.699. Same with this thing, 9. And log base a of 2 is 0.301. Guess I should have zeros in front of all those. And then all I have to do is add those up. So that's what, 14, 17 something? 0.17? No, 1.7? I think. Something like that. All right, question number 14. They ask you to... Oh, that would be the product law, right? Product law, so you just put them together. So it would have to be this one, because you put them together and you get that. And then they say, simplify if possible. Oh, okay, so I have log base a of c squared minus cd plus d squared times c plus d. So I think to simplify, they're basically saying FOIL all this stuff out. So this times this c cubed, this times this plus c squared d, and then let's do this one times this one. So it'd be a minus c squared d, and this one times this one would be a minus cd squared, and then d squared times that will be a plus cd squared. I'm just putting them in alphabetical order there. And then the last one would be plus d cubed. So these are the same but opposite signs, so they cancel. Same with those, cancel. So really, I would have at the end log base a of c cubed plus d cubed. Yeah. All right, hopefully that helps you with those log questions. Takes a little bit of practice. Try some of the quizzes. Access the e-text. Look for more examples of questions that you can try using these laws of logs. We get to use the laws of logs in the next section of 5.2. 5 where we solve logarithmic equations.